We solve problems all day, every day. But have you ever actually stopped to think about how we do it? How our brains go from being totally stuck to finding a solution? Well, today, we're going to dive deep into the psychology of problem solving. It's quite a ride.
You know, it's not a new idea. Over 100 years ago, the philosopher John Dewey absolutely nailed it. He said life is pretty much just one long series of problems to solve. And he's right. From the tiny stuff like what to make for dinner to these huge, complex challenges at work, our lives are built around finding answers. It's not just something we do, it's how we learn and grow.
Come on, you know the feeling. You're staring at a problem, hitting a total brick wall. You've tried everything you could think of, you're getting frustrated, maybe you even just give up and walk away. And then, bam, out of nowhere, the answer just clicks. It appears in your head, fully formed. So where does that magical flash of insight actually come from? That's the big question we're tackling today.
To really get that aha moment, we have to start at the beginning. We're going way back to a time when scientists thought problem solving was, well, a much messier, more random process. And believe it or not, it all starts with some very clever and very hungry cats.
Okay, so take a look at this. This is a puzzle box. It was designed by a psychologist named E.L. Thorndike way back in the late 1800s. The setup was simple. He'd put a hungry cat inside and a nice, tasty piece of fish just outside the door. Now, to get that fish, the cat had to figure out how to pull a string or push a latch to open the door. So, what happened? Well, the cats didn't sit there and stroke their whiskers thinking about the mechanics of the latch. Nope, they went wild. They clawed at the bars, they pushed, they thrashed around. Basically, they tried a bunch of random stuff. And eventually, completely by accident, they'd happen to hit the lever and the door would swing open. It was pure chance. So Thorndike's big conclusion from all this was what he called trial and error learning. He argued that the process was gradual, it was accidental, and this is the key part, it wasn't guided by any real thinking or understanding. It was just mindless action until, poof, a reward appeared. But, you know, that explanation just didn't sit right with everybody. It felt incomplete. I mean, sure, it might describe a cat in a box, but does it really capture what a human brain does when it's wrestling with a complex idea? A new group of psychologists had a very, very different idea. These were the Gestalt psychologists, thinkers like Wolfgang Kohler. And they looked at Thorndike's cat experiments and basically said, whoa, hold on a minute. They argued that for creatures with more complex brains, like us, problem solving involves something much deeper, a moment of genuine insight and understanding. And this slide lays out the difference perfectly. On one side, you have Thorndike's slow, random, accidental stumbling. But on the other, you have Kohler's theory of insight. Here, the solution isn't gradual, it's sudden. It's not an accident, it's a purposeful action. And it's something you remember because it requires you to actually see the problem in a whole new light. Kohler did his own famous experiments, but he used apes. He'd put some bananas just out of their reach and then leave some boxes or sticks lying around. And the apes didn't just flail around randomly. They'd often just sit there, kind of look at the situation, and then in a sudden flash, they'd get it. They'd realize they could stack the boxes or connect two sticks to get the banana. It wasn't an accident at all. It was a true aha moment. And you've had this feeling. Think about a tough riddle or a math problem, or even just trying to rearrange furniture in a room. You struggle, and then all of a sudden you just see the answer. It becomes perfectly clear. That's the powerful and insightful experience Kohler was talking about. Okay, so we've got the brute force, trial and error approach on one hand, and the sudden flash of insight on the other. Modern psychology has kind of combined these ideas into a really powerful framework that any of us can use. It gives us a way to literally map out any problem we're facing. So here is how it works. This modern view says that literally any problem, no matter how big or small, can be broken down into these four parts. You've got your initial state, that's just where you are right now. The goal state, that's where you want to be.
Operators, those are all the possible moves or actions you're allowed to take. And finally, restrictions. Those are the rules of the game you have to follow.
When you put all of that together, what you get is something called a problem space. This image is a fantastic way to picture it. Think of the bottom as your starting point and the top as your goal. All of those branching paths in between, those are all the possible sequences of moves you can make to get to the solution. Your job, then, is to find the most efficient path through this entire space.
Of course, it really helps to be clear about where you're starting and where you're trying to go. As this cartoon points out so well, if your plan is basically step 1, here's my vague formula, step 2, a miracle occurs, you probably haven't defined your problem very well. Clarity right from the start is absolutely key.
All right, so you've mapped out your problem space. Now what? How do you actually find your way through it without getting totally lost? You definitely don't want to just wander around randomly like Thorndike's cats. You need a smarter strategy.
Yeah, just trying stuff at random is a terrible idea for most problems. It's just not efficient. The smart way to search that problem space is to use something called a heuristic. All that means is a mental shortcut or a rule of thumb. It's a strategy that helps you cut through the noise and focus on the paths that are most likely to lead to a solution. And one of the most powerful heuristics out there is called means-ends analysis. It sounds complicated, but the idea is super simple. You just keep asking yourself one question. What's the biggest difference between where I am right now and where I want to be? Then, you take one step to reduce that difference. You're basically breaking the big problem down into a series of smaller, much more manageable sub-goals. This is the perfect analogy for it. Imagine your main goal is to have a full stack of 5 plates. Well, you can't just make that happen. You have to create a sub-goal. Put down the first plate. Then another sub-goal. Put the second plate on top of the first. Each step, each sub-goal you achieve gets you closer to the final solution. And honestly, we do this all the time without even thinking about it. Let's say your goal is to fix a flat tire. You automatically know you have to create sub-goals. You can't put the spare tire on until you've taken the flat one off. And you can't do that until you've loosened the nuts and jacked up the car. Each step is a necessary sub-goal on the path to the solution. So there you have it. We've gone from cats randomly stumbling around in boxes to apes having these brilliant flashes of insight, and all the way to a modern, practical framework for thinking. So let's wrap this all up into a simple toolkit that you can start using right away. Here it is, your 4-step plan. Number 1, get super clear on where you are and where you're trying to go. Number 2, brainstorm all the possible moves you can make. Number 3, use that means-ends analysis to break the big goal down into smaller, bite-sized sub-goals. And number 4, pick your best path and just give it a shot. It's really an amazing journey when you think about it. Our understanding has evolved so much, from seeing problem solving as just dumb luck, to recognizing the power of that aha moment, and finally to building a structured map that can actually guide our own thinking. The more we understand the process, the better we get at it. So, the toolkit is officially yours. You have the map, you have the strategies. The only question left is, what problem are you going to solve first? Thanks for tuning in.